Good morning, guys. Hope all are fine. Today we have our lesson is 12.4 geometry, inscribed angles. Our objectives are find the measure of an inscribed angle in a circle, definitely. Use inscribed angles and their properties to solve problems. These are our objectives, and the student has to be able to know and implement all of that. Our vocabulary, we have inscribed angle, intercepted arc, or subtended arc. We're gonna know these meanings definitely. We'll skip this. Here is a detail. The definitions. Inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. It means this angle, the head of the vertex of that angle is on the circumference of the circle, on the line of the circle, and it contains from the point and the two chords, two lines inside the circle chords. Intercepted arc, the arc that facing the angle, opposite to that angle. It means the lines of that angle will be subtended or intercepted by this arc. So it consists of two endpoints that lies on the circumference and on the sides of the intercepted of the inscribed angle, and all the points of the circle between them. Definitely, the chord or a chord of that arc subtends an angle of its endpoints, lies on the side of the angle, and we're going to know all of these meanings here. We can see that the inscribed angle DEF here, you can see it in this green part. So I have shaded it, and we can see that the intercepted arc is the DF, that at the endpoints located between it, and the DF subtends the angle, the arc DF subtends the angle DEF, definitely. Okay, so here we have again that it is the inscribed angle, and we have to show you something else now. Let us zoom in and go here. See, the measure of an inscribed angle is half the measure of the intercepted arc. What is the meaning? If the arc here, AC, the blue one, if this blue arc AC is 50, so its measure is half of the 50, which is 25 degrees, and this is a degree measure. So measure angle ABC is half of the arc, the measure of the arc in degrees, which is 25. This is case 1, and definitely we can see that one of the chords here is a diameter. This is one case. The other case, we have both of the chords are regular chords, I mean not a diameter, in the space of the circle inside. One of them on the above the center, and the other is below the center. And the third case also is the same. Also the measure of ABC also is half of the arc AC, and definitely here the same. Now here ABC, both of the chords are on a side of the center, but inside the circle, and also it's the angle is half of the arc AC. So for these three cases, all of these are inscribed angles, and all of the vertices here, BBB, they lies on the circumference of the circle, and all of them, they are intercepted arcs, is opposite, and they are subtending the arcs AC, all of them. Example number 1 here, find the measure of arcs and inscribed angles. Find each measure. Measure angle PRU. PRU is this yellow angle. I can make it here, for example, a green or whatever it is. And we can see that it is subtending the arc PU. And since the arc is 118, and since they want PRU, which is an inscribed angle, so definitely it's half of 118. So according to the rule, we can see that measure of PRU is half of the arc in degree PU, which is half of 118, as we can see here, which is equal to 59, and we can see that the 59 is here. It's clearly can be seen, and it is 59 watts, 59 degree. Okay. Here definitely we have substitute. And what do we name this theorem? Half of the angle of the inscribed is half of the subtended arc. We name it inscribed theorem, and we can see it here. It is inscribed theorem. Here the same. Now we have the subtended. Sorry, we have the inscribed angle, and we want the subtended arc opposite to it. Definitely it has to be double of it. So we're gonna say, since we have measure of the inscribed angle is given 27 SRU, and its subtended arc then it's gonna be double of it. Or we can replace, we're gonna see measure of angle of SRP is half of the arc. Okay, we have this given angle 27 equal to half of the arc. Now we can swap, cross multiply, cross product is 2 times 27, which is 54. So whether mathematically or just mentally, immediately we're going to know double of 27 is 54 in either way. So the measure of the arc, required arc is of MS, sorry, the measure of SP is 54. And here we can find, for example, this is 118. How much is this angle? We have found it previously here. So this is half of 118. And we have found it previously, 59. So it depends. Find each measure here, ADC, similar. Now ADC is all of that blue arc. You see it? All of that blue arc, most of the circle, till the point C. So here definitely we're gonna calculate. We're gonna say that measure of angle ABC, the red one, if we subtract or if we remove, it means the arc ADC is the major arc, and the minor arc is ABC. So we're gonna say that the angle ABC, as you can see, it is opposite, or it is subtending the arc ADC. So this is the connection, and we can see that here these are the points of the red points. We can see these end points of the angle subtending the arc ADC. So it's opposite to it. Definitely it's going to be half of it. So the measure of all of it, we can say that we have the angle, we should find the rest, because we don't have ADC, the arc, and they want the arc ADC. How we can find it? It depends on its intercepted chords or arc or subtended arcs. The subtended arc is ADC. Who is inscribed angle opposite to it? It is ABC. So we're gonna say definitely measure angle ABC is half of that major arc ADC. So this is 135, which is given here. You can see it is given, and we can say that this angle is half of the given arc, it means this arc is double of that angle, which is 270, and by this we have found ADC, double of the inscribed angle, which is 270, as we can see. And then we give homework for students. We have given that to students. And this is definitely wrong. This is 0.4. Measure angle DAE here. You can see that the inscribed, the intercepted arc is 76, so half of it is 38, as you can see here. And half of the 76 is 38. They want DAE, and which is here 38. Here we have corollaries for intercepted arcs. Many inscribed angles. You can see if inscribed angles of a circle intercepted the same arc, so they're intercepting the same arc AB here, they're going to be congruent. The angles, the inscribed angles going to be congruent. So angles C and D and E, all of them are intercepted the same ABC arc, so they are congruent. So you can see that if the angles ACB, and let me name it better, angle 1 here, angle 2, angle 3, if you can see that angle 1 and angle 2 and angle 3, all of them are intercepting the same arc AB, you can see here. So the angles are congruent, as you can see. So angle 1 is equal to angle 2 is equal to angle 3 for ACD, ACB, ADB, and AEB. All of them are congruent. Okay, and that angle CAE is congruent to angle CBE, the same. It means if we are talking about CAE, it's subtending the arc DE. Similarly, you can see that CBE, the arc, CD. You can see these angles are congruent. This one, all of that, angle 4 and angle 5. You can name them angle 4 and angle 5. Also are congruent. Subtending the same arc DEC. CDE or EDC. The yellow shaded arc. Similarly, we have concluded that any inscribed angles are subtending the same arc, they are congruent. And here this example, which is somehow a little bit complicated, so let me skip it and go to a more clearer one with an obvious figure. Here we have find measure angle ABD. We can see that ABD is this bluish here, or whatever it is. I made it blue just to show you. And the vertex is B, you can see, and it is subtending the arc AD. So since the inscribed angle ABD is half of the arc, subtended arc AD, we're gonna say it's half of 86, which is 43. So the angle B is 43. Clear? Similar. This is the first one. This is the first requirement. Second requirement. Second requirement is arc BC. And the arc BC, you can see here is the green arc. It's not given, but its inscribed angle that's subtended the same arc BC is 60. So the arc is double of the inscribed angle. So we're going to say 60 is equal half of arc, measure of arc at BC. It's going to be double of 60, which is 120. And we can see here it is 120. As you can see here, it's greenish. And it is found. So by this we have realized how to find a missing arc measure subtended by inscribed angle from the inscribed angle, double of it, or the inscribed angle, half of the subtended arc by degree. Here we have this theorem, definitely an inscribed angle subtends a semicircle, and semicircle means 180 degree. Definitely half of it is 90, so it's going to be right angle. Any inscribed angle gonna be right angle if it's subtending a semicircle, like here, or any semicircle if it's subtending an inscribed angle. It means the angle measure is 90 degree. In this example here, as you can see, an example for the semicircle, you can see that the measure angle Z is given 5a plus 20, and they want us to find a, and we can see the inscribed angle here, WZE, or the angle Z, whatever you name it, is subtending a semicircle which is WY, and its central angle is 180, as you can see here. And definitely half of 180 is 90, so we're going to say, to find a, we're going to say 5a plus 20 is equal to 90, since the inscribed angle is subtending a semicircle, and semicircle is, as you can see here, inscribed a semicircle which is half of 180, which is 90. So 5a plus 20 equal to 90, 5a equal to 70 after going to other side, and we divide both sides by 5, a equal to 14, and by this we had found the measure of a as it is required. We can check, substituting, we can say that 5a plus 20, it's equal to 90. Is it equal to 90? To check, we can see here we are checking, and we're going to say, definitely after substituting the value of a, which is 14 here, we're going to say it is 5 times 40, 70 plus 20 is, and you can see clearly it is correct. Here also we have this inscribed angles to be found. Here we have find the measure of angle LJM. Similar, we can see here we are following the corollary that if two or more inscribed angles are subtending the same arc, so they are congruent. So they want us to find LJM. We can see that the angle LJM is a very small angle here. Its measure is 5b minus 7 given. Okay, and we have another angle, so we cannot find it because we have only just an expression 5b minus 7. But we do have another angle which is k, subtending both of them the same arc LM. So since they are subtending the same arc, so we're going to equalize them, and we have equalized them. We're going to say that angle LJM, this one, and angle 1 and angle 2, let me name them better. Here angle 1, here angle 2. We're going to say that angle 1 equal to angle 2. They are subtending the same arc. You can see they are subtending the same arc LM. You can see here the same arc LM. So they are congruent according to that corollary. So when they are equal, we can equalize them. This is a 3b. 5b, take 3b other side, going to be 2b minus 7 equal to 0. 2b equal to 7, so b equal to 3.5. When you substitute b for each one, 5 times 3.5 minus 7 is 17.5, and minus 7 is going to be 10.5. Definitely there has to be 10.5 because we said according to the theorem they are congruent. Let us check. 3b is 3 times 3.5 is 10.5. So we can see here that both of them are same. They are equal. So they are congruent. Here another example, how to find the same. This inscribed angle is subtending a semicircle, which is 90. So we're going to say hz minus 6 is equal to 90. Substituting, as we said here, a semicircle, which is 180, and half of the 180 is, I calculated here to you, you can see it here. Half of 180 is 90, you can see. And it's written here, 90. And here, hz minus 6 equal to 90, hz equal to 96, divided by hz equal to 12, and by this we have found the measure of the z, and we can check 8 times 12 is how much? Minus 6 is 96, minus 6 is 90. So we have realized that it is correct. Similarly, we can find many measurements, many angles. Here we have this. We have find the measure of angle EDF. EDF, which is green, shaded, 2x plus 3. Since it's an expression, let us check who is subtending. We have another inscribed angle G, subtending the same arc EF, and its expression is 7s minus 2x. Sorry, 75 minus 2x. You cannot say only have one unknown, which is x, or variable. So they are equal according to the theorem. Inscribed angles subtending the same arc. So 2x plus 3 equal to 75 minus 2x. We can see that 2x and 2x, if I take it here, going to be 4x. 2x plus 2x, 4x, and 75 minus 3 is 72. X equal to 18. So we have found x, but they want us to find EDF, and we substitute here 2 times 18 plus 3. Here we have evaluate 2 times 18, 36, plus 3, 39. So this angle measure D is 39. Let us check G, and it has to be 39 because we said they are congruent. We can check 75 minus 2 times 18, 75 minus 36 is also 39, and we can see both of them, they are congruent. Their measure is the same, and by this we have found the missing inscribed angle. Last theorem in this lesson, cyclic quadrilateral. A quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Every opposite angles here are supplementary. D and B, they are supplementary. A and C are supplementary. It means the sum of them is 180. D and C, the sum of them is D and B is 180. And angle A plus angle C, inscribed angles, the sum of them is 180. And since they are on a circle, this is the condition. So the sum of the opposite angles is 180. And we can say here the conclusion, angle A and angle C are supplementary. We can see here supplementary. And angle B and D, they are also supplementary. Supplementary, it means here 180. The sum of them. So here immediately in this cyclic quadrilateral given, and the circle, find the measure of GH, GK. It means all of the angles. Whenever we say the measures, S, plural, it means we have too many measures. All of that quadrilateral, or cyclic quadrilateral, means all of these 4 angles. So they gave us the 3 of them, 3 expressions. We're going to take each pair of opposite, sum of them is 180. So we took G and J, sum of G and J, measure of G and J is 180. Substitute 3b plus 25 plus 6b plus 20. Again, the sum not equal. Common error. Immediately students, they said equal. No, the sum of them, addition, we add them, equal to 180. Okay, avoid this common error, please. The sum, supplementary, means adding. So we add. The sum is 180. Definitely 3 and 6b, 9b, plus 25, 45 came from 25 and 20. Take 45 other side. 9b equal 180 minus 45 is 135. Divide by 9, b equal to 15. Since we have found b, we can substitute here we can say here immediately, here 10b or 6 times 15, and like this plus 6 times 15, it's 90. Here we can say 6 times 15 plus 20. 90 plus 20 equal 110. This is 1. This is 6b plus 20. Okay. Now it's equal to 110, and we have checked it here. Similarly, 3b plus 25. You can check it here also. 3b plus 25. 3 times 15, 45. Time again 10, 15 plus 25. So it's gonna be 45 plus 25. It's gonna be 70. Now 70 and 110 together, these together, sum is equal here 180. Okay, so we can see that it is 100%, it is correct. Sorry, you can see it's correct. And then we give optional homework per student, the sheets A, B, C on the school portal, and they solve them successfully, and we check them for the students, definitely. And similarly, we can find also here 10b minus 69 because we have found b, and then the total is 360. We subtract from 360 h to find the inscribed angle h, and by this we can find all of that. And you can see here opposite here 110. Now they have checked it. The sum is here 170 and 110, and here it is 180, as I said, the sum. The last angle K, as I said, it is 10 times 15 minus 69 equal to 81. So here we have found that this is 81. So this is 110. This is 70. This is 81. And the other one we can subtract it from 180, or we can, so yes, easier. It becomes here 99 here, and we can see here it is, so the angle H, it is 99. After we subtracted, the sum of them is 180, because we have found K is 81, and we substitute K is 81 here, and we can find, because the sum opposite angles of a cyclic quadrilateral are supplementary, as we said previous theorem. And by this we can find too many measurements. Here the same opposite angles here. Which opposite angles do we have here? We have angle M and angle K, which is this one. And angle M is 4x minus 13. Okay, how we can find it? We have to equalize them. Okay, we can equalize them to find the measure. They said it is similar. It is 16 here. I think I have jumped. Yeah, I have jumped it, sorry. Here the opposite angles here, K and M here, we have to equalize them. Sorry, again, my mistake. The opposite angle, the sum of them of the quadrilateral, they are 180. The sum is 180. So the sum of them 180. 4x plus minus 13 plus 6x plus 33, or 33 plus 6. So under 180, it means 10x. The x part here, 10x. The numbers 33 minus 13 is 20. So 10x plus 20 equals 180. 10x equals 160. X equals 16. Substitute here x. Here, another slide. Substitute x by 16. 4 times 16 minus 13 is 51. So the first one, m, is 51. The other one, 33 plus 6x. And 6x, the total is 129. And if we add these together, they have to be 180. We can see definitely this is 180. Sum of opposite angles are supplementary. Now to find the third angle here in yellow, which is L. To find L, 9 times 16 over 2. It's gonna be 114. 9 times 16 divided by 272. And to find the measure angle J, here in red, we are subtracting from the total, or we can take it 180 minus 72, 108. And anyway, either you take it opposite as supplementary of a cyclic quadrilateral, or we add all the angles that we found, which is 252, subtracting it from the total 360. So angle J gonna be 108, and either way we have found it here. Realizing that we can find it in two ways, whether opposite, the sum of opposite are supplementary 180, or we can subtract the missing angle from the total 360, as we have done here. The sum is 252, subtracted from 360 is 108. Finally, we have given these quizzes to students. Angles that are subtending, RUS, you can see it's subtending this arc 50, definitely is going to be half of, and they solved it successfully, and they made it tremendous answers. And the same, we can find that the measure angle A, measure angle T, is subtending a half circle, which is a semicircle, so it's 90. And we can say that this expression to find A is equal to 90, and then we calculate to find A. And by this is one of the quizzes, and the last quiz also here. Many inscribed angles subtending the same arc here, and you can see that we have angle M and angle K. They are subtending the same arc. We can find it. We can find both of them. Both of them are 19 measure angle, but they want a KJN, and KJN is here. Subtending this arc. And we can calculate to find here. We can find it, and the student, they have done it successfully. Yes, it's not inscribed, but it can be obtained by many triangles here, and the student has done it. Whatever, I think that the objectives were done to students, which is to find the measure of inscribed angle and to use inscribed angles and their properties to solve problems. And they have solved all from 2 to 40 questions, not only even for the textbook, and all the sheets of ABC. All of them were found and were answered successfully by students. Hope it is understood. To be continued inshallah for the next lesson. All the best, gentlemen.